Talk about what we've been doing. Is that better?
Yeah.
Okay, so we're going to talk about deploying the INAM fabric monitoring tool on our environment at OSC. And so before we start, I'm going to give you a little bit about OSC as a supercomputer center and the resources we provide, because that has influenced the design of our InfiniBand fabric, which you'll see is not quite as clean as a lab InfiniBand fabric where INAM was developed. We kind of threw a few wrenches in to give them a little more challenge. And we'll talk about the deployment of INAM at OSC, and then Dr. Na will give a demo of INAM. So the takeaway here is, so we've been around as a supercomputer center almost as long as the big national centers. We are a little smaller. We serve primarily the state of Ohio, academics and industry use in the state of Ohio. And we provide the usual things that you get at a supercomputer center. We have clusters, we have storage, we do training programs, and we have a gateways team and a scientific applications team that both have operational workloads and development collaborative workloads with researchers. A little bit about our base right now. We have 23 universities in Ohio with projects that use our system. We have several industry clients. We have other collaborators. Our Ohio researchers work with people all around the country, so we have users from a lot of other schools outside of Ohio as well. And we have a significant course load as well on our system. So a lot of our university faculty, they use us for research, and then they teach a course and they say, oh, can we use you for our coursework? And in particular with our on-demand gateway, they like that because it's a low learning curve for students to get up to speed and run on our clusters. The systems we have currently in operation, some of you saw yesterday, a few more of you will see later today. We have 3 clusters, 3 different generations. They're all Intel chips deployed between 2014 and now. You'll see there's kind of a 2-year cadence. That's because the budget we get, the capital budget we get to buy new systems is on a 2-year cadence. So typically that's we spend and we augment what we have every 2 years. We're actually working on planning for a purchase relatively soon for our 2018 purchase or our 2020 purchase. We're also in the process of upgrading our storage. We have, this is the current operations is parallel file system project in Scratch. Home is a NAS file system, so it's not on the InfiniBand, but we have GPFS project in Scratch directories now. And we're upgrading that. It'll be with a newer now spectrum scale file system of 8 petabytes we're waiting for delivery of. So about our fabric, our parallel file systems are shared across all 3 clusters. And what that does is it means we have one fabric across all 3 clusters. So even though we have different generations of systems with different generations of IB, they are all connected because they are all connected to our parallel file systems. So currently, we range from FDR on our Ruby system to EDR with ConnectX-5 on our newest Pitzer system. And we have different topologies within each of those clusters. different switch sizes with the different generations and different products available when we do the purchases. We're currently using Mellanox UFM as our fabric manager. Basically, actually, the complexity of our fabric made us decide that we needed help from Mellanox to actually manage our fabric, and so that's the route we've gone. From INAM, this is a picture of our fabric. So we have the Owens cluster. We actually have kind of, it shows in there in two places. I'll explain why when I talk about the Owens fabric in particular. The Pitzer cluster is about 260 nodes. The Ruby cluster is about 240 nodes. And we have storage, again, connected to that fabric. So what looks like kind of the center of that fabric is a combination of the center part of Owens and then where all the clusters come together in the fabric. The Pitzer InfiniBand connects to X5 EDR. This was deployed last summer, went live last fall. And so it has support for all the modern Mellanox features. We've hit some wrinkles actually with some of those features, given our fabric and the older generation things connected to it. So we haven't yet turned on all these. We just recently deployed the new MVAPICH GDR, so we've been testing that. This InfiniBand, this is Pitzer's relatively small cluster, so we just have a 2-level InfiniBand, and then from the level 1 to level 2, it's a 2-to-1 oversubscription. Owens is our biggest cluster, so it has a 3-level InfiniBand. It's also EDR, but it was in the first switches and HCAs available for EDR. Doesn't have we don't have as many features. It's a modified fat tree. It basically has 2 compute islands. So when you saw that diagram, there's sort of a big chunk of nodes connected to the first island, which is fully populated, and then the second island, which isn't completely fully populated. And from the leaf switches to the level 1 internal switches, we have 3-to-1, and then we have level 2-to-1 from between level 2 and 3. Those are the oversubscriptions there. And then finally, our Ruby, our oldest cluster and smallest cluster, again, 2-level topology, 5-to-3 oversubscription between the leaf switches and a level 2. And that's an FDR IB. So a couple years ago, we started working closely with the MVAPICH team on the family project, which is thanks to NSF for the support of this collaboration. And the goal was to take INAM, which the team had developed and had demonstrated capabilities, and make it scale and be more robust, so it was and better suited to production environments. And so the MVAPICH team members on this, Puya, Kaushik, Nick, Hari, and Professor Panda. On our side, Trey Dockendorf is in our system administration group, and then Heechang and I from the scientific applications group. So the deployment, we have INAM running. INAM has multiple components. They don't have to all run on the same server, but we have them running on one of our infrastructure servers. That's a behind-the-scenes server. In that server, we have a web server for INAM. So when you see the demo, Heechang will be connected to that web server. There's a database, a MySQL database, and then there's a daemon that collects the fabric metrics running. It's connected to our IB fabric, so all of the nodes and all of the IB hardware that you saw described on all the clusters, and including the file system servers are connected. We get statistics from all those, and then our batch servers. We have 3 batch servers, 1 per cluster. So even though it's 1 fabric, 3 different batch servers running to produce jobs there. So in tying fabric data to job data, we need to be able to query all those batch servers to understand what's running on what nodes. Some challenges or things that had to be developed for our environment. There was no Torque MOAB interface, so that's the scheduler we're currently running. So at the time we started, INAM supported Slurm. So we had to do development there. And development, I should say we, when I say we had to do development, the MVAPICH team had to do development there to make this work. And supporting the multiple batch servers, supporting something I think probably particularly to our environment, but our jobs were alphanumeric job names, and they had only support for Slurm, which was all numeric job names, job IDs. Additionally, actually, we'll probably throw a further wrinkle. At some point, we may have a different scheduler for one of our clusters, because we may change schedulers in the future, and we will leave the old systems on the current scheduler. So we're going to probably add more complexity there going forward. Data collection. You'll see in the improvements that were introduced as a result of this collaboration is being able to set a collection interval that would allow us to gather from this fabric. So there were some tuning and improvements that the team did so that we could collect from all the fabric counters and ingest that into the database. Currently, we pull at 30-second intervals, both the batch servers and for the IB switches. And recently, in fact, just very recently, we increased the storage we made available for the database so we can have longer histories maintained. Some of the things that came out of this collaboration from things we saw in deploying it was improving the fabric discovery, the time taken for fabric discovery that was updated to take advantage of OpenMP to get some parallelism there, increase fabric discovery times. The fabric diagram is cached so that it can be pulled up really quickly in the web interface and then only recreated if changes to the fabric are detected. So, and the fabric changes, right? Nodes go down, nodes, even switches can go down. So, database optimization, so using some tuning on the database to allow us to ingest data quicker and then keep up with the data creation. And then some stuff about packaging and making deployment easier. So changing the packaging to make it more consistent with what sysadmins are typically used to seeing, and making it so it was easy if we had some kind of an outage to restart things. And with that, I'm going to turn it over to Heechang to give us a demo.
Okay, so I'm going to show you the INAM demo that we installed on our clusters. So INAM is running on the web server, so we can access INAM from the regular web browser, but currently it is installed so that it can be accessible only from our login node. So we use our open on demand virtual desktop to open a virtual desktop for INAM. So click here, then we got here. So this is the main page of the INAM, and the most interesting feature is this network view, historical graphs, and live jobs. So I'm going to show all these three features. So for the network view, it requires a little loading time. But as Karen mentioned, it's a lot faster than before. So this is the entire network configuration of our cluster. So as Karen pointed out, this is picture, this is Ruby, and this is ONS, and there are a couple of storage nodes, and those are also ONS. And so this is the live status, and we have link usage, and those link usage is showed by the color, and so that 0 to 5% of link usage representing this gray color, and indicating about 75% of all network use, under usage. So that when I click over this graph, and then this low usage link is just disappear, and if I click on other things, and then currently it show only yellow part that has 50 to 75% usage, like this. So if I'm wondering what's going on into this part, and then we can zoom in. Okay, can zoom in, and then hover over to that node. Okay, let me zoom in one more time, and then hover over this zoom, and then it shows the what's the node number, that is R0131, and the job ID is 0, means there is no job is running actually. And then if I look at other, and then job ID is 181 something, so that we know that this particular job is run on that node. And then when we like to see what's the actual status of this node, and then right click, and then open node information, and then it shows the detail of the port counter information about on the on that node, so that it shows data sent and the data received. So this blue line is aggregate. So this is the data amount that is sent through that link. So this is the summed over the time, and this yellow is the delta. That is the data amount summed data amount during the data collection period. So currently it has 30-second data collection time. So every 30 seconds is showing the data transmitted and received. So essentially this yellow line is a derivative of this aggregate graph. Okay. And then go back to here. So we see that the node information, and also we can see the link information. So on the go into that particular link and then take the right click and then open link information. And then it shows the link information every 30 seconds. So this is the switch to the node, and then here is the node to switch. So this is the send, and then upper one is receive. Also, we can go to the particular switch, hover over the cursor over the switch, and then it shows more detailed information about the LID and GUID. And then again, right click and the open node information, and then it shows the information of the switch. So that the switch has many ports, so particular ports connect to the particular node here. And there are other ports that connected to the other switch. So if you are wondering what's going on this port 9, and then it shows the send and receive information like this. Okay, but as you see, there are many nodes and many switches. How can we address a particular node? Is that we have searching, searching box here, and then we can click name, and then we can search for ON node, something starting 3, 4, 9 here. Click it and find the node. Yeah, so here have a highlighted color 3, 4, 9. So we can find out particular node information from here like this. Okay. I will be visiting this network view section with job ID searching by the job ID a little later. So then let's look at the live job section. So let's close these jobs. Live jobs. On the live job tab, it shows all the currently running jobs on our 3 clusters. So you see that there is 1,247 jobs running. So this total number of jobs are from all 3 clusters. And then, so that this job ID without any characters, that's a Ruby job. And if I searching for picture, and then picture here, picture job ID appears. Or if I put ONs, and then all the ONs jobs appears. So I have prepared some example job on ONs. Let's type the one job ID, and then it identify the currently running job. This is a 4 node milk job that is running. If I click it, and then it shows the 4 node that is running. So there's some CPU usage information, virtual memory usage, but this feature is for the MVAPICH. I will show what it looks like a little bit later, because currently on OSC, MVAPICH is not running. Okay, but here port counter, and I see it, and then it shows like this. So each time I show, it's showing very boring, plots, but this one actually sending and receive using the network quite extensively, so that you see that this is a 4 gigabyte. So on delta, and the measurement time period is 30 seconds. So essentially 4 gigabyte per 30 seconds data transmissions occurs right now. Okay, And then using this current job information, I will copy it. On the network view, I can select job ID and then put the job ID number here, refresh, and then the network configuration of this particular job appears. So from here, I can dive in to this particular node by right-click, as I showed you before, and you can look at what's going on to this link. So here, I think it's green. So OK. So if I click everything, and then it will display what level of communication are going on by the color. So from here, all 4 links are active between 25% to 50%. And also, so this is the maximum data receive and send. And there is some receive, error parts, error part, so receive error, and then the link usage options changes. So there is error and no errors. Everything is black, so that there is no error. We see that there is no error. And if there is error, then it will marked with red color. Okay, and then and the other interesting thing is I had another 4-node milk job, and it was, so this is the not live job information, it's previous job information. So it was the same job with 4 nodes, but it actually used 7 switches. So the job performance should be lower than the previous one, right? So if you find that some of your benchmark were worse than previous, and then you can see that the network configuration very quickly, so that you can find out what's going on inside of it. Okay, and then let me show you this historical graph for the jobs. Okay. So I have 2-node LAMPS job running before, 5, 5, 9, 6. Women's batch 10 OSU. And then automatically it pulls out the start time and end time. And then the send data and the receive data is showing like this. So as you see, send and receive has very similar pattern. Like there is 2 hump from the middle, the peak from the beginning and the middle, and there is a lower bump here and lower bump here, right? But there is a subtle difference between sending data is from the bottom, but the receive data is curved like this. So as you see, it's 2-node job. So if we see the other node, and then send and receive should be opposite. And then we can change the node. Okay, change the node. Then clearly see that it's opposite. So kind of a cute sanity check that we can do on this. And the 4 nodes job that I showed you before has higher higher usage on the bandwidth. Okay. Sorry, this is not the one that I was looking for. 6, 4. Okay. I think I need to reload it. Okay, so as I told you, the bandwidth was like a 4 gigabyte per 30 seconds, and after the job finishes, the communication bandwidth is lower to 0 like this. Okay, so then let's switch out to another job that we prepare with the MVAPICH 2X, so that I'd like to show what kind of extra feature that we can see on the with the MVAPICH 2X. Okay. So this is a particular job that it is currently running on 2 nodes. So it shows the CPU usage by the job level and also by the node level. So the first node and the second node CPU usage is displayed here, and also this virtual memory usage for the job level and node level. Okay. And then there is a process counter. Process counter show this data sent and received here, and also we have a port counter here. So this port counter and this process counter give kind of similar data, but this process counter is only MPI. So that this port counter is everything from the InfiniBand fabric. So this port counter might containing the disk I/O data as well, but this one is pure MPI processes. And also all right. Yep, you need to wait a little. Job ID for the particular job. So this is a 2 node job, and if I look at this link information, and then it shows the switch to the node and the node to switch information. And here we have, this is the network level, and we can check the job level. If that particular node has multiple jobs, and then it will display multiple job list here, and which job taking the bandwidth from the full bandwidth. And also we can see the processes level, and I check the job, and then it will show individual lengths length information about the data, the bandwidth usage. So here is 0 to 8, and this is the 8 to 10. So I think this is everything that I like to show you in this demo. So any questions?